Off-Road is an SAE team at South Dakota State University that designs and builds an off-road racing car each year to compete against other colleges. We give students the chance to apply the engineering skills learned in classes to real-life scenarios. This year, Desert Hair Off-Road sponsored a senior design project to create a robust and reliable suspension system for our competition vehicle. This system had a few main goals in mind. The club wanted to have at least 10 inches of ride height to clear smaller obstacles and 10 inches of travel to absorb large impacts. The Baja vehicle also needed to incorporate a four-wheel steering system. Common obstacles at competition include large drops, jumps, rock pits, mud pits, and whoops.
We also participated in the National I-Corps program and interviewed potential customers and industry professionals. During these interviews, we learned that people value suspension that is effective, robust, and easy to maintain. These reasons, along with needing to accommodate four-wheel steering, we decided to build an A-arm suspension in the front and the rear. This allows for easy manufacturing and serviceability. Dual spring shock absorbers were chosen because of their easy adjustability.
To ensure our system would keep the driver safe from large impacts, we simulated the car on a virtual track to get a good estimate of the forces seen during worst-case scenarios. SOLIDWORKS finite element analysis was used to see how our components would react to these forces. Through 3 main design iterations, we were able to create a system that can withstand a 15,000 Newton cyclical impact and a 7,000 Newton frontal impact. This system was then fabricated in the Architecture, Mathematics, and Engineering shop and installed on the competition vehicle.
After the suspension was built, we wanted to test it physically to see how it compares to the simulation results. To simulate a large drop, the car was pushed off the AME loading dock at around 10 miles per hour. The first trial resulted in a ball joint popping out, so bands were added to keep them captive. Further trials did not result in breakage. On the test track, the vehicle rolled over. This resulted in a bent tab on the knuckle, so side gussets were added to strengthen them. Overall, the suspension system was able to perform well on the track with a ride height of 12 inches and 12 inches of travel, exceeding our original goal. We are looking forward to showing our vehicle off at competition this year.